So we just reviewed our exponential functions. Now we're going to get into logarithms. They are inverses of each other, which is why we do them together in the same unit. So a logarithm is an inverse of exponential. And this is going to come up on the other side of the paper. So let's just review it real quick. We did this last unit. How do you find an inverse? What do you do?
Switch y and x.
Switch y and x, right? Because we're going to do that on the other side of this paper. So the purpose of a logarithm, it is a way to isolate, which means get by itself, an exponent. That's like kind of the point of it. You want to get the exponent by itself. That's what a logarithm does. Because everyone gets all upset, like, why is this word in my math problem? And I get it. Like, but that's what a logarithm is. It's an inverse of an exponential. It's a way to get the exponent by itself. The base number cannot be negative. And we talked about that last time. So whatever your base number is, that can be, you know, whatever you want, but it can't be negative. All right, and then there's two kind of special ones. Your common base is 10. So if it's not written, it's understood to be a 10. So if you just see log x like that, like there's not a base number written, it's understood to be 10. The reason for that is we have what's called a base 10 number system. We have 10 digits, 1 through 9, and then 0. And our numbers recycle every 10. That's why it's easy to count 10, 20, 30, 40. Cool? Do you know why it's 10? And why 10 is super logical for us? And why 10 just feels right? Everyone's like, well, 10 just feels right. Like, it just makes sense.
Because that's like my 10.
Yeah, but why?
What's that? 10.
And that's why they're digits, right? So your common base is 10. And then your natural base is E. And that one is written different. It's written ln of x, but that means log base E. It's like log natural, ln. I actually don't know why it's ln. Natural log, I guess log natural. Anyway, the purpose of today is to simply get you comfortable with what a logarithm is. We will do the graphs next time. That is all today is to get you comfortable with a logarithm. You did these like a teensy bit in algebra too. Do you remember sort of like log, the word log? Anyway. So if it says write in log form, you're going to need to write the word log. And this is basically just getting all the pieces of the puzzle in the right spot. You want to do the base first. When you look at this, which number do you think is the base? The 2, the 3, or the 8? The 2. It's a subscript. I sometimes say the base goes in the basement. It's down there. I know that sounds so stupid, but if it helps you remember, then it's great. Okay, that's the base. Leave a little bit of a gap, put in equals, and the point is that it's going to equal the exponent. It's a way to isolate an exponent. It's going to equal the exponent. It's going to equal the exponent. I'm just going to say that over and over again. So which number is the exponent?
3.
3. And if you get the base and the exponent in the right spot, there's only one other place to put the other number, which is the 8. The way we say this is log base 2 of 8 equals 3. Not that I'm going to yank you in the hallway and make you take a verbal exam, but that's how you would say it. So we're just practicing getting everything in the right spot. That's it. All right. So for number 2, write the word log. What's the base number?
4.
4. So little subscript. It's like an anti-exponent. Leave a little gap. It's going to equal the exponent. So it's going to equal what? What's our exponent? -2. And if you get those in the right place, there's only one other spot for the other number, which is the 1/16. So it's log base 4 of 1/16 equals -2. Let's try the next one. This would be log base what? It's 36. Leave a little gap. It's going to equal the exponent, which is the 1/2. And so the 6 has to go here. Let's review that really quick. Why is this true? 36 to the 1/2 equals 6. Because what does this mean? Square root. Your square root of 36 is 6. Let's review the negative one as well. 4 squared is 16, but what does the negative do? Flips it, okay? Because it's going to come up. All right, this one is base e. So you're going to write ln. That's what log base e looks like. Ln, leave a gap. It's going to equal the exponent, which is 4. And so that 54.598 is going to go right here. The reason it's a decimal is because e is a decimal. It's 2.718 ... to the 4th power. So that's going to not be a nice number. And then what's the base for that last one? 10. You're not going to write it. You're just going to write log. For base 10, we just don't write it. Leave a gap. It's going to equal the exponent, which is 3. And so 1,000 goes in that spot right there. Here's the trick for the base 10 ones. Whatever the exponent is the number of zeros you have. Do you see that? When the exponent is 3, there are 3 zeros. Okay. Now we're going to write them in exponential form. That means you better have an exponent in there. What is the base for number 6? Since it's not written, 10. The logarithm equals the exponent. So whatever this equals, that's your exponent. So your exponent is 2. And so it's 10 squared equals 100. Now these are a little easier to check, go in the other direction, because you can be like, well, is 10 squared equal to 100? Does that make sense? Yes. If you got like 2 to the 100th power equals 10, hopefully you would be like, no, something is not right. All right, what do you think about this one? Yep. 5 squared equals 25. 5 is the base, 2 is the exponent. I think it's a little easier to go this direction. All right, this one would be 49. And then what? 2 to the 1/2, which means square root equals 7, which makes sense. Square root of 49 is 7. All right, oh, how about this one? What is the base for this one? E. It is e to the power 1.945 equals 7. And then this last one, 2 to the power -3 equals 1/8. 2 to the 3rd is 8. The negative just means you flip it. Now, I wrote all of your exponent rules out here. I'm just going to go through them real briefly, and I'll just make up a couple examples that like we can just do verbally. All right, because when we flip it over, you're going to have to know how to do these. When you multiply, you add your exponents. So funny, we're doing this in Algebra 1 right now. Multiply, you add your exponents. When you divide, you subtract your exponents. A power to a power means you multiply them. A negative means that you reciprocate. You're going to flip it over. And then these are your roots. Your roots are the fraction ones. Okay, so let me just make up a couple of examples. What would be 16 to the 1/2? You don't have to write these down. I just want you to look and listen and pay attention, because when we flip the paper over, you're going to have to know how to do this. That would be 4. Why is that 4? Perfect. Square root. How about 27 to the 1/3? It would be 3, because it's cube root. How about 5 to the -2? 1/25. 5 squared is 25. The negative means you flip it over. How about 8 to the 1/3? Cube root of 8 is 2. How about, I don't know, 5 to the -3? Yep, good. Okay, cool. We understand how that works? Because we're about ready to do that with logarithms. All right, go ahead and flip it over. When it says to evaluate a logarithm, and like put hearts and stars and unicorns next to this, your answer is the exponent. That's the whole point. You're looking for the exponent. Your answer is the exponent. So the result, the thing you're looking for, that's the exponent. So when you look at that first one there, log base 2 of 64, what that's asking you is 2 to what power, what's the exponent, will give you 64. We're going to just count on our fingers. Ready? 2 to the 1st. 2 squared would be 4, 8, 16, 32, 64. What's our exponent? 6. You see how we just counted on our fingers to do that? Your answer is 6. That's all you're doing. What this one's asking you is 81 to what power will give you 9? Why is it 1/2? Because that's correct. Square root. Good. This is asking you 3 to what power gives you 1/27? Ooh, why is it negative? Because it's a fraction. You flipped it. What's the base on this one? 10. To what power gives you 10,000? Now, do you remember the little trick I said? How many zeros are there? 4. This is asking 17 to what power gives you 17? 1. Yeah, anything to the first power is going to be itself. This is asking 12 to what power gives you 1? 0. Anytime you see a 1 there, it doesn't really matter what the base was. Your answer is going to be 0. Anything to the 0 power is 1. And then this one, do you see how there's an ln and an e? Do you remember me saying how exponential and logarithm are inverses? They undo each other or cancel out, and your exponent is just 9. Remember, the answer is the exponent, so it is just 9. Don't overthink that. That went like so well that I'm almost a little nervous, but we're going to play a game in a second, so we'll see. I guess we'll see how it shakes out. All right, and then this last section is find the inverse. You're going to switch x and y. If the problem is exponential, your answer will have a logarithm. If the problem is a logarithm, your answer will be exponential. There will be a point where you get stuck. Everyone's always like, not me, I'm such a genius. No, you will. You will get stuck. It's part of the problem. And when you get stuck, not if, do you notice when you get stuck? The question that gets you unstuck is, what's the base? What's the base number? I used to always bring up that Meghan Trainor song, but as time goes by, that song gets older and older and older. And like half of you probably don't even know what I'm talking about, but do some of you know the Meghan Trainor song? That's all about that base. Anyway, so think about Meghan Trainor, but do you get what I'm saying? It worked many years ago when that was new, but anyway. What's the base is the question that will get you unstuck. So scribble out f of x, call it y. You're going to switch x and y. So it'll be x equals 1/2 to the y plus 1. And then you're trying to get y by itself. We're not stuck yet. What would you do first? Yep. Subtract over the 1. And now you are stuck. And that's fine. That's like part of the process. What is the base? 1/2. Since this was exponential, our answer is going to have a log in it. The base is 1/2. So you're going to write log base 1/2. Leave a gap. You want it to equal the exponent. So what's the exponent? Y. Do you see that there? And then whatever you didn't use goes in that gap. So what did we not use yet? Yeah, the x minus 1. Now you will need to give that a hug because it's the whole thing. Y is by itself, so that's our answer. Only thing is, and again, I won't mark this wrong at all, but what did we find? Yep, good. Yeah, with that little -1. If you don't want to write that, fine, but technically what we found is an inverse. So instead of y, I'll be happier in my soul if you write inverse. This one has e in it, just as foreshadowing. What does that mean the answer is going to have in it? It'll be logarithm, so ln. This one's going to have ln in it. All right, scribble out f of x, put y. We're going to switch x and y. We're not stuck yet. Sometimes you are. Sometimes you're stuck immediately. But we have a couple steps we can do. What would you do first? Add 7. And then you can do one other thing. Yep, divide by 2. So x plus 7 over 2 equals e to the y. And then you're like, hey, I'm stuck. So the base is e. It's going to be ln. Leave a gap. It will equal the exponent, which is y. Now you can write y. I'm going to put inverse just to be thorough. And then the stuff we didn't use is that x plus 7 over 2. Do you see how both of these are logarithms? That means the answer is going to be exponential. This one will have a 4 to the something. Like the base is 4, it's going to be 4 to the something, like just as foreshadowing. You can do that to kind of check your work. All right, so switch x and y. It'll be x equals log base 4 of y plus 3. All right, then what? Yep. Minus 3. Then you're stuck, which is fine. As long as you remember the question to get yourself unstuck. What is the base? 4. It'll be 4 to the power, because it's exponential, x minus 3 equals y, or inverse. And then again, as foreshadowing, this one has an ln in it. So what is the answer going to have? The answer will have e in it. If you lose your mind entirely, make up something that has an e in it. All right. So switch x and y. And then subtract 2. And then I'm stuck. So what's the base? E to the power x minus 2 equals y plus 8. And we actually have one more step in that one. The others, we were finished after we did that, but there's one more step, which is to subtract 8. Can you combine the minus 2 and the minus 8? No, good. It'll be e to the x minus 2 and then minus 8 equals inverse, or if you put y, fine. I don't know why I circled that one and not any of the others, but it will.